ladies and gentlemen, welcome back to another live stream. So I haven't streamed for quite a long time now, so hopefully everything is fine. So I'm gonna share the stream with my Discord. You can find the link down in the description below to join my Discord server. Okay, sick. And also we could put it even in the Zig programming language streams, why not? And yeah, okay. So let me try to pop out the chat here. And yeah. So the stream would begin in a few minutes, pretty much. Let me check if it's working out well. Okay, I think it works. Yep, working. So I guess we'll start already. I just have my coffee right here. So I haven't touched like Vulkan with Zig for maybe 2 years now. So I wonder how the ecosystem have changed and the code have changed and stuff. So we'll be exploring together that thing. So yeah. Alright, so I'm gonna bring the chat here, sick. Now let's try to start a new project, pretty much. Hello, Theo Paris. Is the stream fine? Because I haven't streamed for a long time. I was really waiting for someone to join, let me know. Okay, cool, love that. Alright, so let's see what we got. Where do we even start? So this is gonna be a chill stream. I am gonna try to not explain too much. So if you guys just have any questions, please let me know. Hello, Lurmog. Welcome to the live stream. So I pretty much just want to do this project because I'm curious on how Vulkan and Zig have evolved since I've touched it 2 years ago. That's the first thing. And second thing, I just wanted something to get me back into the momentum of coding, because lately I felt so sluggish, it's so slow, so stuck kind of. So I really wanted something to kind of get the ball rolling again, And there's no better way than doing it with creating a crazy Vulkan program, because first of all it's so huge, and second of all I'm very familiar with it, generally, because I have done it several times. Because the thing is with Vulkan, once you get a triangle on the screen, you're already tired, so freaking tired, man. It's insane. But it's so good to learn a new language, just get back into the momentum of coding and so on. But yeah, we could also try new Vulkan extensions. If you guys have any questions or anything, please let me know. But yeah, might have a chance that the Vulkan lib doesn't build with the latest Zig. Oh my god, are you sure about that? I have no clue. It's I haven't tried it. I wanted to do all of this stuff with you guys on stream, pretty much. So I don't know if we're gonna even have any triangle today. So I guess let's find out, So let's find the Zig Vulkan binding, really. Hopefully not. So I really don't want to deal with tulip problems, because oh my god. But anyways, let's see. So this is the Vulkan binder we're going to be using pretty much. I have forgot how to even use it, but we'll find out. Four hours ago, last commit. Okay, seems fine. Yep. Vulkan zig generator. Oh boy. Okay, so we probably should start here. Okay, let's try to start a new project then. Fine. cd dev and let's mk. Okay, wait, I'm gonna complete my coffee really quick. Okay, is there like some other maniac that like drinks coffee at 2 a.m.? Anyways, what version of Zig do you have? Oh yeah, that's a really good question, because for anybody who's like, you know, watching this stream in the future, because hopefully this would be saved. I'm not sure, but it may be saved. So pretty much 0.15.2, but yeah. Alright, so Zig init. Well, in fact, we should create like, I don't know, Kodotaku Zig vk. Okay, and let's go inside of that, Zig vk, and let's just say Zig init. Cool. And now let's just launch VS Code right there. There we go. Yes, I trust the author. And let's hide the secondary bar, and there we go. Okay, so we're gonna remove all this junk. I really wish there was like an empty template. Like there is one template that they just added recently, but it's so empty it doesn't even have like the executable build.zig thing. It's like, bruh. Anyways, so we got root.zig. In fact, I could even remove, or you know what, let's not mess with that. Fine. Anyways, let's try to actually right now add Vulkan zig. So I'm just gonna copy this line of code, or this command, and yeah, cool. Now let's just copy this part and let's see what's gonna happen. Let's see the fireworks. Okay, all right, let's paste this here, and apparently we need path to vk.xml. Yeah, I don't like how Zig's initial template has root.zig either. Yeah, it's not just root.zig, but like all the comments and all that craps. Like, there's always this problem with the templates. I'm not sure, like, did they use these templates or what? Like, bruh. We really need some sort of like, I actually like noticed that even I was trying to some React stuff and so on, and I even noticed that there's no empty template like that just gets you going, you know, no crazy comments. So it's either like very minimals, like basically nothing, or it could be like bloated basically. But yeah, it's meant for 0.16. There's a Zig 0.15 compact branch. Oh my god, you probably saved me a lot of headaches, my god. Okay, before you could have choose between a lib or exe template, but now it's a lib plus exe template. Yeah, so apparently since we're using 0.15.2, we're gonna go with Zig 0.15 compact. Okay, because like the master seems like maybe it's for 0.16. So I guess let's seal the commit right here. And hello, passing no. Welcome to the live stream. That's a long name. So we're pretty much just gonna be having like a chill live stream where we try to make a Vulkan Zig application. I did make some few live streams about Vulkan and Zig like 2 years ago. So hopefully we could figure out today together, but yeah. Okay, alright, so how are we gonna do this? Okay, let's go to build.zig.zone, I think. And here we got the hash. I think I basically gotta do this. So I basically just got the hash of the 0.15 branch. I think that's probably how it should work. And now we gotta figure out the way to get the path to vk.xml. And for that, I'm probably gonna need like to install Vulkan development packages. So in like Arch Linux, you say sudo pacman-s vulkan-devel, stands for development, and it would basically install everything. Would install Spurvy tools, Vulkan ICD loader, etc., etc. I'm just gonna go with the defaults and yes. It's also gonna install the layers and so on, so that's sick. Oh boy, that was a long time since I've touched this Vulkan stuff, especially with Zig, but yeah. Alright, so now we gotta figure out where is the vk.xml. Wait, where is vk.xml in Arch Linux? I forgot completely where it's located. What's the default? Bruh. Is there something about that there? Wait. Path to vk.xml. Could it be in share? Ooh, wait a second. Let's see this. What the heck was that? Vulkan SDK. I mean fish shell, so I'm not sure if that's the way it's done, bruh. Okay, how about this? Vulkan SDK path. Why don't you GPT? I mean, honestly, I guess fine. Let's GPT it. Arch Linux vk.xml path. So /usr/share/vulkan/registry/vk.xml. Okay, that's sick. So let's make sure that it does exist there. Oh yeah, there we go. You might need to reference the library in those. Yeah, I'm definitely gonna do that. But there we go. So yeah, it's pretty much right here. So I'm just gonna copy this path. I'm gonna put it here. Whoops. Put it here. And there we go. So add import vulkan exe.root module. Perfect. So I think this should work. So now let's try to zig build. Hash mismatch. Oh yeah, I didn't change the hash here. So I think maybe I just gotta comment this out and it would kind of like give me the hash itself, maybe. Yeah, expected hash. I'm gonna copy this. Okay, zig build. What? Oh wait, what the heck? Why didn't you copy? Bruh. Okay, we got some error apparently. Is expected to be relative to the build route. Bro, what? But was the absolute path. It is best to avoid absolute if you must. What? Is expected relative to the build route, but was this absolute path? Is there like, is this some new zig change or something? Okay, what's the problem? p.path. Oh, you know what? I think we should basically copy vk.xml into our project too simply. Yeah, so let's just do that, fine. Let's just do that, vk.xml. And we're gonna basically cp this to /vk.xml. Yeah, so here we go, cool. And now we could too simply just use it. Yeah, I guess you could just copy, yep, pretty much. All right, so hopefully this works. Zig build. Okay, what's up again? No dependency named Vulkan zig. In all packages used in build must be declared. Vulkan is the readme wrong or something? It's called Vulkan though. Okay, and now what? Oh, I haven't saved main. Now let's just make a main function. So pubfn main, and well, void, or an error. And yeah, okay, so it seems to be working now, at least it's building. So that's sick. Okay, so how are we gonna import this now? We called it Vulkan. So let's try to actually import this. Const Vulkan is equal to import Vulkan. There we go. And let's just try now to say Vulkan dot. Okay, so right now we have access to Vulkan. That's sick. So now how are we gonna deal with the windowing? I think we probably need SDL. Yeah, or GFW, but I'm gonna go with SDL honestly. Binding can be generated directly from the Vulkan headers repository by adding Vulkan headers as a dependency, and then adding the path to vk.xml from the dependency. Ooh. We could also like include the Vulkan headers directly into our project. So like whoever is trying to build our project doesn't need that, yeah. Should we do it? Or you know what? If it works, don't touch it. Okay. Alright, is there anything else that we should be... Get the lazy path, get generator. Yeah, I think we should be good so far. So now we probably need to just like set up SDL3. So let's look for SDL3. Bruh, come on. So a machine is basically asking me if I'm a human being. That's pretty interesting. Anyways, SDL3 zig. Let's look for SDL3 zig. And there's this one, but I'm not sure if it's gonna work for our purpose. But we could use another one, like the raw bindings. Where are the raw bindings? Let's see the raw bindings that this guy uses. Build.zig.zone. Yeah, it's called cast home. These are the raw bindings. Okay. SDL port to the Zig build system. So I'm just gonna copy this part and basically add SDL into my build, and then I'm gonna add a dependency in my build.zig. There we go. Now what we got here, b.dependency SDL. Okay, we don't need SDL3 test, we only need SDL lib, and for that I think we basically need to say, what GPU do you have? I have NVIDIA RTX 3050. Pretty much nothing fancy. Anyways, so how do we link a library? There we go, link library, and then you just say SDL lib. There we go, cool. So I think that should give me SDL2. So SDL is import SDL fully, and well, we probably still need some extra thing, maybe, no? Oh, I think we're just supposed to like include, yeah, you're just supposed to use like C include, because this basically only like replaces the part where we link to the system libraries, but it doesn't replace the part where you like C import the headers of SDL. But yeah, though I wonder if we could like use Zig translate C to like translate the SDL3 header, because I've seen this around like as like a trend in the Zig ecosystem where they just, instead of using C import, they just translate the file and then just use it. But yeah, all right, so I think this should work. Let's try the Zig build right now. SDL from source. Okay, it's taking some time because it's building from source, obviously. Now, the real advantage of building from source is debugging, for example. You could step through like even SDL code, and obviously you're using the Zig build system. Okay, we have that problem of CRT and so on, because I'm on a bleeding edge system which had some breaking change in GCC, and Zig built-in compiler doesn't like that, which is the built-in one, but it's way faster, but it's broken right now. So we're gonna say, not here actually, let's go to the exe. Wait a second. Okay, back. All right, so let's see where we have this. Okay, let's say use LVM is equal to true and use LLD is equal to true. And this would fix that error. All right, sick, we're good. So now let's actually try to make, I guess, some window. So SDL, but no, we can't like just import SDL like this. We have to use that C import. But wait, can we actually use that Zig translate C? Expects exactly one source file, but how would that work exactly? I'd like to try that. You know what? Let's just chat GPT. How do you translate SDL3? Can use import C. Yeah, I could use import C, but let's try to actually do it this way, because I've seen that people are more leaning towards this way recently for some reason. And honestly, it's kind of cleaner. So Zig translate C. Oh, well. You know what? Let's just do whichever I know right now, which is just C import. Fine. Fine. I love to explore. Anyways, so C include, and we're going to go with SDL/SDL.h. I think SDL3, no? Maybe. And yeah, that's pretty much it. Now let's try this out. SDL init. Yeah, let's just call this C. Let's say C. Oh yeah, SDL init like this, and C.SDL init video. Now this obviously could return a boolean. So if this gives out like false, so we can basically return some error. Error.SDL init, or too simply error SDL, fine, and Zig build run. Okay, so everything's working fine, cool. So now what I'm gonna do is I'm gonna have a little helper function for check SDL or something like that. So let's say fn error SDL, and we're gonna basically say void error, and let's say std dot, well, we don't have std yet, so let's say std is equal to import std. Okay, and here we're gonna say log dot print, right? Dot error, yeah, dot error, and here we give it the format. We're gonna say SDL error, some error, and here we're gonna say c.sdl get error, too simply. And yeah, I believe that's basically it now. So yeah, that's fine, but I'd like to honestly make an error route, really. So can we just return error.sdl, and then we could too simply say this, try error SDL. Is that the deal here? Let's see. Expected tuple, oh yeah. Cannot format pointer without a specifier. So we're basically printing it as a string, and we're good to go. All right, so let's try to actually create a window now. So c.sdl create window, and here the title is, let's say, code.taco. The width is 800, the height 600, flags c.sdl Vulkan flag, so window, I guess, window Vulkan. And we probably also want SDL window, std debug print for printing. I think this is good too, no? I think this is more for maybe release builds or something like that, but yeah. Anyways, so SDL window, resizable. And also it's gonna be hidden at the start, and then we're gonna basically show it later on. Okay, so how are we gonna do this now? So const or var? Const, let's go with const. Const window is equal to this, and we could, no, should we? Let's just say if window is equal to null, then we're gonna basically say try error SDL, and we're good to go. Yeah, I think that's basically it. Now let's try this out. Okay, so this works out, cool. So we also need to load Vulkan, like the Vulkan library. So how are we gonna do that? Well, if not c.sdl, what is it called? SDL Vulkan, I believe. Please don't tell me it's not, it doesn't include SDL Vulkan. Let's see. C SDL3 SDL Vulkan. There we go. Cool, lovely. So Vulkan.h, and let's go. SDL Vulkan Lloyd library, and here we're just gonna say null. So now what this returns, it returns boolean. So if not that, we're just gonna say try error SDL. Though, what do you think? Should we make like an fn check SDL, which would check for this? So let's just say, I don't know, retch boolean void, and it would basically do, let's see, if not retch, right, then we're gonna basically say try error SDL. That's it. So we could basically say right now check SDL instead. I think that would be better, so we don't need this stuff now. Does that seem fine? SDL create window. How about this one? I mean, we could make one for that too. So SDL ptr retch, and it's gonna be like some sort of, well, some t, or we could say maybe any type, or what should we do here? We could say probably any type, so fine. And what we're gonna do here is if rec is equal to null, then we're gonna try error SDL. Though actually, it would be even better if we like return. So you know what we could do? Let's just say comp time t type. Please let me know if there's like a better way to do this. But yeah. So here we're gonna say like a pointer t. And what we're gonna return, and this is basically gonna be optional, right? And we're gonna basically remove that optional part, and we're only gonna return pointer t. And so basically what we're gonna do here is if ret or if ptr, then we're gonna basically get the in-wrapped ptr, we're gonna return it, else we're gonna basically try error SDL, and at that point, yeah, it should be fine. Cool. Alright, so I believe that's it. Now what we could do is check SDL PTR. Now here it should be c.sdl window, I think. And here the PTR would be this. Now the nice thing about this is that it would check if the window is valid. If it is, then it's gonna return it without the optional. Hello, the Gecko1. Ramadan Kareem. Alaikum salam. Welcome to the live stream. Okay, so I think this should work. Let's see, but actually I'll just say c.sdl show window. Now one thing that really kind of like sucks about SDL is that everything returns an error. So even like show SDL here, so I guess fine. What does this mean? It's just like a religious kind of month, pretty much. Yeah, in the Arab world. Sig build run. Function cannot return an error. Oh yeah, let's add that. Now what? So parameter type declared here. Wait, what? Type info, type off. Wait. Oh yeah, I gotta try this. Okay, what's now? Function with non-void return type. Error union error set implicitly returns. Okay, well we're just gonna say unreachable here, because we're sure that the error SDL with error. But yeah, okay. Why the heck? Was it actually not able to create the window for real? For real? What? SDL create window. Huh, that's interesting. Try check SDL. Bro, what? Wait, where's the error of SDL here? Error, SDL, error, nothing. Yeah, so it's definitely like a false positive. Probably missed out something here. Oh, it happened here. It happened in Lloyd. I see. What the heck, bro? I thought I was cooked. Especially that I have Wayland. But yeah, it seems to be working now. Great. Okay, so after we load the library, we need to grab the SDL Vulkan instance, vacate instance proc ADDR. Let's go. Now what this returns? It returns an SDL function pointer. Cool. So const get proc ADDR is equal to that. And now we could basically use this to grab the function pointers of Vulkan. But in fact, we should be able to like pass it to Vulkan. So now let's figure out how we could use Vulkan though. Alright. Where do we even start here? Let's see. So there's dispatch tables, wrappers. Oh my god, that's nice. Base wrapper. Okay, so we say base wrapper.lloyd. Cool. So let's see if we could do this. So like Vulkan, or shall I say vacay? Fine, let's call it vacay. Wait, so it's 4 a.m. for you? Yeah, pretty much 3 a.m. I'm a night owl, a vampire. Okay, so where's vacay? There we go. Vacay dot vacay.base wrapper. Okay, so let's check out the base wrapper here, and we need to load it using some loader. And our loader here is from SDL instead of GFW, so we're gonna pass in the get proc ADDR hopefully, and let's hope that works. So what this returns exactly? I guess it just returns the vacayb directly, probably. So we could say vacayb is equal to that, and if we're good, then we should be able to get the, well, enumerate the instance version, let's say. Okay, let's try that out. Cannot call optional type. I see. So this is optional. So you know what we could do? We could use our check SDL PTR again. And let's just say try. And it basically unwraps it for us if there is no error, I believe, but we gotta pass in the type, which kind of sucks. SDL function pointer. Yeah, that kind of, you know what? Let's just unwrap it right now. Fine. Okay, and let's see what happened here. Expected 0 arguments found true. Okay, did I forget something else? Bruh, what? Expected 0 arguments found true. What does that even mean? Oh, it can't actually. Oh my god. So this is actually could error. So we're gonna say try. It's very hard to read these errors, bruh. Expected 0 arguments found true. So what's up now? But why? It's very strange. Is that an error from the lib itself? Yeah, I believe so. So basically, instead of using GLFW, we're using here like SDL. So expected 0 arguments. Found 2. Oh boy, that's strange. Maybe you need to wrap the get proc ADDR in a zig function. Could it be that like maybe it's not compiling the right zig version? That's interesting. Should we try ChatGPT and see if it's gonna figure it out? Okay. Where the heck is ChatGPT? Let's see what it's gonna say. Bruh, come on, this is, I already know this. Should look like this. Wrong zig version. Yeah, it could be wrong zig version. It looked like the SDL doesn't take any arguments. Huh. Actually, that's kind of true. Wait. What? Oh, I think we're supposed to like maybe call it? No, what? It actually doesn't return. What the? Bruh. I think we're supposed to like... Yeah, I think we're supposed to cast it maybe. Maybe we're supposed to cast it. So like as comtime t-type. Here actually we're gonna go with Vulkan vk dot. Now we're gonna figure out where is the pfn types. So like pfn get instance proc.ddr. Yeah, okay, let's try this out. Now expected type. What? I'm so confused right now. Let's see if it's gonna figure it out. PTR cast. Wait, what happened here? Expected 1 argument, found 2. So I guess we're supposed to remove this and basically do this. Okay, let's try this out. Okay, so it works now. So we fixed it. Great. Alright, so that works. Lovely. So we basically had to like cast the, you know, opaque kind of like function pointer from SDL into the right function pointer, which is pfn get instance proc.ddr. So this is kind of like the Vulkan function, and this is its type essentially. And so once we do that, we get our function right here, which you could basically like call with any name of any particular like Vulkan function, and it could basically load that for you from the linked library, like the DLL or whatever. And so here the base wrapper is kind of like a zig wrapper over this Vulkan stuff, and it would basically take care of loading that stuff for you. And so right now we have like an interface, a Ziggy interface for Vulkan pretty much. So enumerate instance version. Now I wonder how we could like, because as you can see it actually did print the Vulkan version, but how do we grab, like extract the the minor and stuff like that? Let's see. Version minor. So there is a version type. Is that something that? No, I don't think so. Major. Nope. Version. Yeah, I don't notice anything here that could do that, huh? That's interesting. I wonder if there is anything about that. There's even Vulkan video. I really want to try Vulkan video someday, but it just looks crazy, man. Version. Yeah, I don't think I'm gonna figure this out. So you know what? Let's just move on to the next step. Pretty much fine. So right now what we're gonna do is we're gonna create an instance. So how do we create an instance? We say this, and then we're gonna give it the create info and the allocator. Okay, so here instance create info. Now can we just do this here or no? It doesn't really seem like, so let's just say instance create info for now, like this, and the allocator null, and we're good to go. So vk.instance create info. And whoops, I thought I was in C++ for a second there. And why I'm not getting autocomplete right now? That's strange. Yeah, it's kind of strange. But you know what? We could just... Is there no like builder API in here by any chance? I don't think. You know what? Let's actually see how they actually use it here. Let's see the examples, for example. And let's say... Maybe... Actually, we need the graphics context in this case. I mean, we could just copy this classes, but... let's see. So vkb create instance. Okay, so they just use this kind of syntax. .p application info. Alright, fine. So instead of this, they basically do this, as I thought before. But I'm not getting any support from the autocomplete, which really sucks. Really sucks. Let's see. Instance create. Can we just like copy this whole thing and paste it here? And there we go. Now we could just say .type, .pnext, .flags. Please don't like tell me there is a better way than doing it this way. .type structure type. Okay, so here we're gonna say equal to c.structure type. Well, actually vk structure type dot instance create info. Yeah, pretty much. Next up, the pnext. So for the pnext, we're gonna go with obviously null. And actually, yeah, these have the defaults, so we're good. That's nice. So s-type pnext, so we could just remove that because it's optional. And the flags, no need. The application info, we need that part. Enable layer count, we don't need. Enable layer names, no. The extensions, we do need that part. So just need this one's right here. And here the p application info. Okay, cool. So I guess maybe we could just say this. Yo, I'm making an OS in Zag. Hello, comported box is amazing. Welcome to the live stream. That's pretty interesting. I've noticed like the tutorial about like an OS in Zig, but I haven't got the time to check it out, to be honest. But yeah. Alright, so let's see how we're gonna do this part. Well, so pretty much we need to grab the extension names first of all from, where's p application info? There we go. Okay, so we only need the API version. We're gonna use the latest, honestly, and you just say bitcast vk API version. Okay, so the API version is equal to vk.api version 1.4. Does anybody knows a better way to do it? Because like I have no autocomplete right here, which is insane. I wonder if I was actually using like Zig Vulkan like this before. That's crazy. There's definitely gonna be a better way. But anyways, so now what? VKB create instance create. Yeah, let's grab the extensions right now from SDL. So how are we gonna do that? Well, c.sdl Vulkan get instance extensions, and here it gives you back the count. So the count is just I guess i32 un32. So c.un32, or I believe we could just say u32, yeah, probably. So let's say const, actually not const, var instance extensions u32 is equal to undefined, and then, well, instance extension count, and there we go. I think that should work, and it would return to me the extensions. So const instance extensions is equal to this, and boom, cool. So now where are we gonna do this? So we're gonna say this is equal to instance extension count, and this is equal to instance extensions, and let's see if this works. And we have some problem. Expected type u32 found vk.version. Yep. So we gotta do that that bitcast thing that we've saw there, apparently. And let's go. All right. Misinstruct field engine version. So like that's not optional, really? Yeah, apparently application version, engine version, API version aren't. Okay, sure. So application version, engine version. We could just set it to 0, I don't care, I think. And engine version to 0. Yeah, they're not like significant. And expected type const found const uh cannot cast into pointer type child. What the heck is this incantation? Incantation, bro. Let's see, expected type oh, I see. Just gotta basically make sure that it's not null. And let's see how it does it with GLW, for example. It just does, I guess, PTR cast. Okay. Let's try PTR cast. So what we're gonna basically do is it's equal to instance extensions, and you're gonna say 0 up to instance extension count. And is that basically it? Now let's actually try to use this. Expected type found. Probably we need to pass in PTR, right? No. So I guess let's just do it the way they did it here, which is basically creating an array list first of all. So okay. Var extensions. Extension names, fine. It's basically an std, or we could just say equal to std.ArrayList. And what's next? Okay, we basically say that it's gonna like end off with 0. Okay. Const dot empty. And then we're supposed to basically, I guess, go through all of those. So for Okay, we got a name here now. And then we just say extension names, I guess, dot append. And right now we need an allocator. Okay. So let's just pass in the GPA there. And then the item is the name. So where are we going to put the allocator? Let's say here, for example. So we're going to say GPA allocator is equal to, well, GPA std.heap general purpose allocator .init. There we go. And then we're going to basically say defer, well, actually this should be a var, defer GPA allocator .dinit. And then we could say const GPA is equal to GPA allocator allocator. Okay. So obviously there should be try. And what's next? Now, how did it use that part? Let's see. So just PTR cast it. Interesting. Yeah, I should have probably just PTR casted it, but yeah. Anyways, let's just do it. PTR cast. PTR cast what? Extension names. Probably dot items, yeah. And maybe even dot PTR. And yeah, let's try this out. And GPA dinit, let's just say, well, actually cd.debug.search that this basically is equal to dot okay instead of leaking memory. And yeah, consider using try. Okay, so vkb create instance try. Yeah, value type vk.instance ignored. Yep. So let's just say that this is the actual Vulkan instance. Now, and use local constant. Obviously. And yeah, memory address leaked. So let's just make sure to deinitialize this stuff. Where is the extension names? In fact, what I wanted to try though is, can I just like pass in instance extensions directly? Because if we do, then we don't need any of that extra business, to be honest with you. So PTR cast instance extensions. And yeah, apparently it seems like it does. So that's cool. So I guess we could just remove all this business, though we could keep the allocator. Fine. Now instance extension, oh well, not all that. Wait, where's the, okay, so apparently we only gotta remove this part and this part. Alright, so and use local constant GPA, sure, let's just say this. It's so annoying. And yeah, alright, so everything is good now. Let's make sure that we have the vk configurator on. Does it actually like, because I have installed like vocal devil package, so it should come with it, but I don't see it here though. Maybe I have to basically like launch it here. Yeah, GY. Okay, do you want to download? I mean, I guess no. And let's just go with the API dump and let's see if it works. So now let's go back here and let's try zig build run. And as you can see, right now I could see all the Vulkan calls and it's successfully calling Vk create instance. Okay, so that was kind of slow, but we're just kind of still figuring things out pretty much. I wonder if we like should use just like this graphics context and call it a day. What do you guys think? Or should we just do it ourselves? So give us the graphics queue, the present queue. What do you think, guys? Should we copy this over? Or should we just do it ourselves? I think. I mean, you know what? We could try, I guess. Yeah. Let's try to actually copy this over. And let's see. So this is like the graphics context.zig. And we basically paste in this. And cool. So now you basically init it, but this expects like a GFW window apparently. So we gotta basically, okay, import Vulkan std, and here's c.zig. Well, here's the C. And well, actually, you know what? Let's make that c.zig file. .c. Oh, what? No, just that, I guess. Pubconst. Now here in graphics context, we could say import c.zig .c, and we're good to go. Now we could pretty much do the exact same thing in the other place. I think. And alright, let's see. So instead of GFW window, we're going to go with an SDL window. Next, base wrapper Lloyd. So instead of base wrapper Lloyd, we're going to pass in this. Okay, get proc ADDR, and there we go. And yeah, so is there any other like GFW stuff? There's this one, GFW create surface, Windows surface. So let's actually use, okay, let's use SDL. So SDL Vulkan, create surface. And here the window is basically window. And the instance is, well, instance, and the allocator, where do we grab? Oh yeah, just null. And the surface. Now this obviously returns a boolean. So if not SDL Vulkan create surface, we're gonna return an error. And yeah, is there another GFW stuff? Let's just call this SDL window. Any other GFW stuff? Oh boy, the extension Sparch. So for that one, let's take our code right here. So where is it? There we go. Any other GFW? I don't think. Maybe that's it. Alright, so let's try this out. Let's just comment out this part and let's see if we could use that one. So let's say const graphics context is equal to import graphics context.zig, because to be honest with you, most of that part is just like boilerplate code. So if we can get that running really quickly, that would be great. Graphics context. And yeah, now let's see if we can actually use that now. Yeah, the graphics context dot init, and here we give it the allocator, which is our GPA, and the application name, which is Kodachaku, and the window, which is, well, our window. And obviously that's the fur, and well, this gives us back the context, I think. So var ctx is equal to try, and the fur ctx.dinit, too simply. And let's see if this actually works. If it does, that would be so cool. Okay, and use local constants first of all. Oh, well, okay, let's actually count this out. And now we have a problem here, pointless. Oh yeah. And let's see what we got. Expected type. Huh. Oh. It's supposed to get the handle, I guess. Next up. Nah, even more than that. I think we're probably need to like cast it or something. Let's try ptr cast that. And let's see. Expected pointer type found. Bro, what? What's the goal here? Attempting the game using Vulkan or what? Just trying to get at least like a triangle in Vulkan with the new Zig Vulkan SDL, you know, binding pretty much. And hello Nate Schreiner, welcome to the live stream. It's pretty much just a chill live stream where we could like ask me questions and so on, and we're just, you know, seeing how Vulkan Zig evolved through the years. Last time I tried Vulkan Zig was like 2 years ago, and right now I'm just trying it again in front of you pretty much. And yeah, that's pretty much it. Okay, let's see what we got here. Gotcha. Your new IO Zig interface. Honestly, I haven't checked out that much on that. Like, I only like look for things that I currently using, so I haven't really stumbled too much on it, except maybe for you know, like saving a file. But other than that, not really, at least not yet. Okay, where is that part? Let's say create surface, I think. There we go, and it's basically saying instance.handle, and that just works. So instance.handle just works. Why it's not working here? That's interesting. Expected C import. So like, how the heck does it work with GFW, but it doesn't work with SDL? That's strange. Yeah, that's weird. You know what? Let's ask ChatGPT. Let's see if we can figure it out. Oh, PTR from integer. Yeah, because like the zig binding handles are integers, or wait. PTR from int. And does that work? Expected type use size found. No. What the heck? PTR. You know what? Let's check out the documentation really quickly here. Let's see, how do you like cast? Is there something about casting? Here's the handles. What? So it's basically an enum use size. Word, I'm working on the storage engine buffer manager in Zig, pushing off the upgrade from 0.15.2 to the new interface. How did you get it so far? Was it easy? Was it hard? Working on the storage engine. If you want to share like the GitHub repo, you can, and I would pass it through the live stream. So if you guys want to share any of your projects, please let me know. Yeah. And I was thinking about actually like making an IO Zig stream or like video. And I've seen a few options, like there is ZIO pretty much. ZIO. That's the one I'm probably going to be using. Isn't the new interface been added in 0.15? There are more changes coming. Well, I think it's more established in 0.16, I believe. But yeah, it does exist though in 0.15. But yeah, I have my eye on this library. There's also the libxif, I think, library or something. Zig libxif. Yeah, there we go. There's also this one. Cross-platform event loop. So this is a little bit lower level than ZIO. ZIO kind of like gives you coroutines and stuff. It's more high level. This one is kind of like libev, which is used in Node.js, and oh, it's actually being used like pretty much by the whole like Zig ecosystem, because this is kind of like just a cross-platform implementation in Zig on top of like the low-level APIs of other like, you know, platforms like Windows, Mac OS, Linux, and so on. Pretty much, yeah. I don't have the new IO parameter interface in 15.2. Yeah. I believe there's also another one. There's also the Zig Coro. I believe maybe it's like newer one. Well, 6 months ago, so maybe it's not as maintained. But yeah. Anyways, let's go back into business. If you guys have any ideas about that stuff, please let me know. It could be a topic for another live stream or something. But yeah, anyways, so where we were here. So why this didn't work? So apparently this handle, it's an instance. An instance is an enum. So in some sense, we need to first of all kind of like maybe convert the enum into a number, I think, or like get the payload somehow or something. Okay, no readers and writers were changed as well as some array listings. Okay, let's see how that works. So enum from integer or int from enum. So right now we have an enum, so we're gonna say enum from integer. Well, no, int from integer, from enum. My god. And we're gonna say instance dot handle. Maybe that's it. ptr from int from enum. How about that? Did it at least fix that part? Expected type C import struct vk surface kchar found vk surface kchar. Yep. So what we're gonna do for that one is so like c dot, can we say c dot surface kchar? Yeah. How about that? And then we're gonna return surface. Can we say maybe vk dot surface kchar, and then like kind of maybe we're supposed to like do the conversion again or something. That's strange. How do you construct this enum? My god. Oh, I think you probably just maybe call it like this. Is that the case? Let's try this out. Type is not a function, obviously. Can we just do the same thing we've done here, pretty much? So how are we gonna do this? So this is vk surface kchar, which is a pointer. So we're gonna convert the integer, so integer from ptr surface, and then enum from int. Can we do that? So maybe that's how you do it. Oh my god, it actually works. Crazy. Well, at least it seems to be doing its job. So we already got a context ready. we would have had to like write all this code otherwise. Oh my god. So yeah, at least we saved a bit of time right there, because what the heck. Context dot. So as you can see right now, we have like a graphics queue, an instance, a mem props, like device properties and present queue and so on. What do you guys think? Should we try to make like use of Div UI and just, you know, make like you know, like a statistics kind of Vulkan thing where it just shows the properties? Nah, let's try to do some actual thing, you know. Okay, so let's maybe also steal the where is it called, the Swapchain from here. I really love the fact that like the Zig Vulkan binding actually included these files. So amazing. It just saves us a lot of freaking time, because, you know, the Swapchain and the context are just like a lot of unnecessary boilerplate code. Okay, so let's just add that too, why not? As for the descriptors and some other stuff like render passes and so on, which also are pain in the ass, we're gonna try to make use of some newer like modern Vulkan extensions if we get into that, which gonna also make it way easier to deal with. So that would be cool. All right, anyways, we're just pretty much let me know, guys, if you like this kind of format where like I have no clue what the heck is going on in the project. Well, obviously I do know a bit about Vulkan, but it was like 2 years ago and so on, like especially with Zig, and right now we're just kind of like rediscovering pretty much. But yeah, okay, so swapchain.zig. So let's see, vk import Vulkan in the graphics context. Yeah, I believe that seems fine. So let's actually right now import the Swapchain here. Import the swapchain.zig, and there we go. So now let's actually try to create that. What? Oh. Well, I see what's happening here. Well, I'm supposed to actually do something like this, you know, graphics context, and then just make it this way. Yeah, pretty much. And we just do this. And here we could say like try swapchain dot, well, dot swapchain dot init in the graphics context here, which is basically CTX like this, and the allocator is, what kind of allocator they're talking about here? Is it like Zig allocator? I think probably. So let's pass in GBA, and the extent here, probably the window extent. So let's just do this for now, and the width is equal to, you know, 800 and height 600, just hard coded for now, and hopefully that works. So defer swapchain.dinit. Are we creating the swapchain? Yeah, I guess so. I think so, yeah. Yep, pretty much. So what does it contain? It contains the graphics context, the allocator, the surface format, the present mode, the extent, the handle of the swap chain, the swap images, the image index, and the next image required, also like a semaphore. Okay, that's quite sick. Oh boy, so the synchronization is already handled for us. That's pretty cool. That we gotta figure out how we could actually use this API. So let's actually see how it's used. So let's see triangle.zig here. Oh boy. So even with those like abstractions, this is all the code of the Vulkan triangle. Still 500 lines of code. Right, they are using, yeah, they are using the graphics context in the swap chain. Though they actually have like a full buffers and so on, but we could make it way smaller by not actually including that part for now at least. Let's see how they've done it pretty much. Let's see. So they're using GFW, we're using SDL3. Well, they're using render passes. We're not going to be using render passes. We're going to be using direct rendering, hopefully, which is the most modern way of doing it. Create frame buffers. Frame buffers really suck. We're going to remove those. And create command pool. So they're calling it GC, graphics context. Okay. Destroy buffer. Create command buffers. Swapchain present. Deployed in the vertices, copy in the buffer. Yeah, like all the buffer stuff we could work without it for now. The render passes too. The pipeline, even the pipeline pretty much. We could just like for now, just focus on clearing the window only. But I need to figure out how the swap chain actually works here. Their swap chain abstraction, how they're using it. So let's see. So here they're initializing the swap chain and de-initializing it then. We don't need a pipeline layout. We don't need a render pass either for now, nor frame buffers. So right now we just got to figure out how we could create the command buffers. And yeah, let's figure that out. Fine. So create command buffers. Let's see. So this is pretty much it. It takes in the graphics context, the command pool. We have to create a command pool, and the allocator, a buffer, an extension, render pass. What the heck? Pipeline frame. What? Why? I thought this was just going to create the command buffers only, but apparently it doesn't. Okay, let's try to actually create the command pool now. Let's try to do that. Alright, so how are we going to do this? So var command pool, well, try vk.command pool.init. Wait, what? No. Okay. So honestly, let's see how they're doing it here really. So command pool, where's the command pool? So gc.dev, so the device, okay. So should we call it, yeah, fine, let's call it gc, fine, gc. And here .dev, so basically this is the, I believe the Vulkan device, yeah. Okay, so we have all the functions right now of Vulkan device. And we're gonna use the create command pool. Now here we got command pool create info, the allocator. So let's just say this, and the allocator would be null as always. And here let's figure out what we're gonna need. So we're just gonna need the Q family index, and we're gonna set it to the graphics context.graphicsQ.family. Cool. So what is it called? Q family index is equal to gc.graphicsQ.family. So it's basically the index right there, and we have the handle of the queue. So that's sick. And here we're gonna say try, and we're gonna basically defer command pool dot. Oh, we can't actually do that. I guess we're just gonna say gc.dev.destroy command pool. Yeah, command pool, and the allocator here null, pretty much. There we go. So that's our command pool. Okay, it's never mutated. Sure, const. Let's make sure that this is working out just fine. Perfection. Let's go to the next part, which is creating, I guess, the command buffers. So how they're creating the command buffers, let's see. Okay, so first of all, they are apparently like allocating memory for it for some reason. Okay, and it's frame buffers dot length. And then we're allocating the command buffers. We're giving the command pool, the level, the command buffer count, and free command buffers. Okay, so the frame buffers. Let's go back and see how the frame buffers are being created. So obviously we don't need frame buffers in our case, but I just want to know what it's using exactly for the count. So let's say create frame buffers, and yeah, it's using the swapchain.swapimages.length apparently. So that's interesting. So basically a one command buffer for every swap image. Alright, sure, let's do that. So we're gonna basically like allocate array, and we're gonna call this, I guess, command pools, and we're gonna say gpa.alloc. Yeah, and the type is, well, I believe vk.command buffer. Well, not command pools, command buffers. But yeah, so here the swapchain dot swap images, I guess, dot len, right? So cool, and obviously it should be try, and this is should be called command buffers. And we gotta make sure to clean up our mess. So we're gonna say command buffers. Well, actually, gpa.free command buffers. Okay. That's interesting. So we're good so far, I think. Next up is let's go back to creating the command buffer stuff. Yeah. And now we could use the gc.dev.allocate command buffers. Okay. gc.dev.allocate command buffers, and here we give it the allocate info, and here the command buffers. Well, just gonna give it, I guess, command buffers.ptr. Is that correct? I mean, I think so. Yeah, .ptr. And now let's just. It really sucks that it doesn't give like autocomplete for this part. You know what? What if I actually gave it the type myself? Would it actually at least autocomplete at that point? Hopefully it does. Yes, it does. Okay. So that's interesting. That's very interesting. So it's only broken when you use that kind of syntax. Fine. So the command pool is equal to, well, command pool. Next up, the level is just primary, though doesn't it already have some defaults? No, not for that one. And the command buffer count. And the command buffer count is equal to, I guess, command buffers.len. And we should int cast that because it's usize. So you gotta cast it into u32 apparently. And what else? I think that's it. And apparently we don't need s-type and pnext really. Oh yeah, because yeah, the binding already actually populate those values by default, unless if you actually override it for whichever reason. So that's pretty sick. I thought I was gonna have to do that for every single one of them. So that's cool. Alright, so now what we're gonna do, so just returns void pretty much, so this should be fine. Next up, we gotta free the command buffers. Okay, sure. So the for gc.dev free the command buffers, and here the command pool. So let's give it the command pool, and here the command buffer count. So the command buffer count, it's gonna be basically command buffers.len, and here the command buffers.ptr, the pointer, and that should do the trick. But we have a little error apparently. Command buffer count. Okay, let's int cast this. And there we go. So that's sick. That's lovely. What's next? So we got our command buffers now. So like apparently what it's doing here. Oh, is it like pre-recording, like baking all the command buffers? I think that's exactly what it's doing here. Yeah. Yep, I see. So no, this actually kind of suck. I mean, it's more high performance, you know why? Because like it's basically recording all the command buffers at once at the start of the application, and then like for every single frame buffer and command buffer, right? But that's kind of problematic because like it's hard to scale, you know. So we should just, yeah, pretty much. Let's actually try to use now, I guess, the Swapchain already. So let's see how the Swapchain works. So where's the Swapchain? We're just trying to acquire an image or something. Where's acquire image, So like, how about the Swapchain stuff? Swapchain init.dinit. Okay. So here's the actual loop. Sure, nice. And what we're gonna do here, so basically it selects the correct command buffer for every, like, so basically baked command buffer. In our case, we're not gonna bake them. we're just gonna re-record one command buffer every frame, I think. Yeah. So if state is equal to suboptimal, extend, try swapchain recreate, destroy frame buffers, try create command buffers. Yeah, so like the other bad thing about this way of baking all the command buffers at the start is that every time like you resize the window, you gotta make sure to like recreate all the Vulkan resources that depends on it, which kind of suck, but yeah. Anyways, so state swapchain.present. Honestly, let's just kind of like copy this part, really, and let's see how we can adapt it. Wait for all fences though. Wait. Let's grab all this. Let's just paste it in here, and obviously we're not going to be using GFW. We're going to be converting that stuff to SDL. So here we got while GFW window should close is equal to that. No, so we're going to just say present state optimal or suboptimal. Interesting. So we're just going to say here while is running or something, or while not should quit, and basically boolean, well, var should quit is supposed to be a boolean and false at the start. So while not we should quit, we're gonna grab the frame buffer size, which is basically the window size in pixels, and in SDL instead of GFW what we do is, did I actually mention, by the way, SDL in my live stream? Did I mention it in detail? Because I probably forgot that part, but I could probably like edit it later, but fine. Anyways, whatever. So here we got get. So let's just say c.sdl get like pixel size, I think. Pixel size, yeah. Window, well, okay, window size in pixels. There we go. And here you give it your SDL window, and here you give it like the width, where you're gonna put the width and where you're gonna put the height. And this is how you do it in SDL, though in SDL it's kind of noisy, everything could return an error. So we gotta say try check SDL. And there we go, perfect. Now if the width is equal to 0 or the height is equal to 0, then we're gonna pull the events and we're gonna continue. Interesting. Where it's calling the pull events again? Yeah, it's calling it also here. I see. So don't present or resize swapchain while the window is minimized. So for now, I'm just gonna like comment this out. But other than that, here, where we're trying to say c.gfw pull events, I actually gotta replace that with the SDL one, which is basically making a new like while loop. And now while SDL pull event, I think. So c.sdl pull event, and here the event. So here SDL, well, c.sdl event. Wait, what's going on here? Oh my god, var c.sdl event, there we go, is equal to undefined. Cool. And what we're gonna do now, so while c.sdl pull event, we're gonna basically switch on the event.type. Now if we got, let's say, well, not case, how do we do this? Well, yeah, c.sdl quit, or like event quit, there we go. We're gonna basically say should quit is equal to false, or actually should quit is equal to true, right? Though I believe since this is maybe an assignment, you gotta be in this guy. Yeah, there we go. Cool, love that. Alright, so I think that's pretty much it maybe. So here we're presenting the swap chain. Cool. So we're gonna remove this part. We're just gonna be re-recording the current command buffer. And we don't need any frame buffers for now, because we're gonna be using the direct rendering. And yeah, pretty much. So let's just remove that part. And let's see what's next. So here we're trying to recreate the swap chain if the state of the swap chain is suboptimal, or the width not equal to. That's weird. I'm not sure what they're trying to do there. But yeah. Okay, so here we gotta grab the command buffer. I think we could probably maybe just reuse one command buffer. Yeah, actually we should create like command buffers like per, not per swap chain image, but like per in-flight frame. But for now, let's just follow in the steps of the example, you know, just to make sure we don't get into some weird thing. So what we're gonna do here is, so command buffs is basically this. Whoops, there we go. Command buffs. Oh boy, should have just renamed that. Anyways, so that should be good to go. Now here we got some extent.width. Where is that coming from exactly? Extent. Apparently, I guess it's just coming from this. Fine. And yeah. Okay, so that should be good to go. I wonder if this would even work at this point. Like, obviously we still need to record the stuff, but let's just see if this at least like compiles and so on. So how do we do this? Whoops. There we go. Okay, so it actually works. There we go. Okay, so that's perfect. But obviously we're not like recording any commands just yet. In fact, if you like make it use the validation layers right now, oh crap, it's still like locked in apparently. Okay, let's make a new terminal. Fine, and let's try to zig build run again. And as you can see, you're gonna see a lot of like validation layers from Vulkan because we're still not doing that stuff right. Well, the thing is, first of all, since we're not using the render passes like the one in the example here, we're gonna be using a newer modern way of doing it in Vulkan, which is direct rendering. So we gotta figure this out. Oh my god, it's like it's been quite a long time since I've used this stuff. So hopefully I won't get stuck. Let's see. So first of all, we need to kind of like enable that extension. In fact, we're going to need a few extensions. I'm going to be using a lot of extensions to make our job way easier with Vulkan, hopefully before we rage quit. So let's see. Where is that? So I guess maybe instance extension, or is it probably device extension? Yeah, I think so. Let's see. Where is the device extensions here? Device extensions. So where we create? Well, here we're creating the device here. And device.init and destroy device. Okay, so I guess maybe it's here. No. Wait. Where is the device info? Bruh, I'm confused. Initialize candidate. Okay, there we go. Okay. Alright, so here we got the extensions. Nice. So how are we gonna do this? So right now what it's doing is it's just taking in the required device extensions. But from where? Where it's getting this? Oh, it's actually hard coding it here. I see. So let's say comma, and I guess maybe we could add extensions here. Dodge. Can we do like... In fact, I think no. You know what? Since we're using Vulkan 1.4, we just kind of like maybe have to enable the... What is it called? The feature of dynamic rendering. So let's see. So like Vulkan dynamic rendering. Let's just look for some sort of C tutorial blog or something like that. Yeah. So I could refresh my memory here. Okay. So this is not it. Okay, there's this. Okay, there we go. So as you can see, we're basically with this extension, with this new Vulkan extension, we don't need the render paths and we don't need the frame buffers. They're very notorious, bruh. So very annoying. So here we added to the device extensions, though since this device extension got promoted to core in Vulkan 1.3, which means you don't really need to add it as an extension because it's already a core extension in Vulkan 1.3. So, but we still need to enable the feature of that. And here it's dynamic rendering features. Now we gotta figure out how we could do this in Zig though. So that's another part of the story here. So here, as you can see, we're using pnext. So obviously Vulkan is like a C API. So to basically keep Vulkan structs like extendable, what they do is they have this kind of like S type and this pnext. So just, you know, a bit of background here. So the S type is kind of like, you know, an enum. So like it could like whatever kind of Vulkan struct, you could basically like cast it to this struct, Vulkan struct type enum, and then you would get the struct type. You know, it's kind of like basically you could get any kind of Vulkan struct and figure out what its type without knowing its like original C type, just from this enum, which is like the first field in the struct. That's basically how it works. Next up we got here this pnext, which basically you could set it to another struct which would basically extend this struct. In this case we're going to extend it with the features. So yeah, it's kind of like a linked list here pretty much. So alright, let's see. So here, okay, let's add that, fine. Let's figure out where that stuff is being done. So this is the device create info. Okay, sure. Initialize candidate, and here we got the create device, and we pretty much need to add .pnext, right? Pnext, I mean, I guess so. Why it's not... Yeah, it's kind of annoying, but yeah, it's probably pnext. But let's just remove it for now until we make the struct. So here we're gonna make a Vulkan features struct for 1.3 and 1.2, etc. So let's see how that works. So Vulkan features 1.3 is equal to vk.vulkan 1.3 features. There we go. And here there's a whole bunch of extension features that you could enable or disable. Now obviously not all GPUs like support these extensions and so on, but if you're like on a modern desktop GPU, you probably do support Vulkan 1.4 and all these basic features like dynamic rendering, which we're going to use here. So dynamic rendering, it's basically got promoted into the core, Vulkan in version 1.3. So basically any extensions that got promoted to core in 1.3, you're going to find them in this struct right here that is called physical device Vulkan 1.3 features. And you could all enable all of them here like together instead of just like having one separate struct per feature, which kind of sucks. Other stuff that we're gonna need is, yeah, we're gonna use synchronization too. That's also the case, and I believe that's it for the ones from the Vulkan 1.3. And as I said before, since they're core, we don't need to add them as extensions, since we're using Vulkan 1.4. Okay, next up is Vulkan features 1.2. I believe I do need some, features from there too. Now, obviously, most, if not all, tutorials you're gonna find out there won't show you like these new modern extensions. Most of them are just showing those kind of like legacy ways of doing stuff. But yeah, there's also this buffer device address, which kind of like allows you to basically just pass in a device, like a buffer pointer straight, like a GPU device pointer straight to the buffer, instead of having to go through descriptor sets and all sorts of crazy objects like descriptors, bindings, and so on. There's also descriptor binding stuff. Yeah, descriptor indexing. Is this the one that I want to use? I don't think so. Runtime descriptor array, scalar block layout. So yeah, I wanted push descriptors. Where's push descriptors? Wait, let me actually find out. Vulkan push descriptors. This makes descriptors very easy. Now, obviously, we're not going to be needing descriptors just yet, because we're just going to be clearing the window for now. But later on, we're going to need it, so we'd better just do it now, I guess. Okay, so here's, I guess, the page for it. And when it got promoted to... Or did it ever got... Okay, so this one actually got promoted in Vulkan 1.4, interestingly. Okay, so let's actually go with 1.4 here. 1.4, and so push descriptor is equal to true. So this would allow us to ignore all the descriptor set business. And yeah. And these are like the other features that got like promoted to core in Vulkan 1.4 apparently. There's also host image copy, maintenance, rectangular lines, smooth lines, prism lines. Anyways, whatever. So this is the stuff that I think we need right now. But wait, how do you... I guess you probably just say pnext is equal to Vulkan features 1.3. And here we're going to say dot pnext is equal to Vulkan features 1.4. But definitely a pointer there, but yeah. So basically this device info struct is pointing to this, and this is pointing to this. Now honestly it should probably be the other way around, honestly, but it should be fine, I guess. So let's try zig build run at least and see if it at least compiles. Expected type wiki.bool 32 found bool. Dynamic rendering. Okay, so I guess we're gonna use wiki.true. That kind of sucks, but okay, whatever. Probably same thing here. Since it's basically an integer, not really a boolean, not an actual boolean. Expected type wiki bool 32 found comp time inch. What the heck? Bro, how they're actually doing that stuff? Let me see the binding stuff. We need some example of a boolean being used here. Well, it is just using true, so I'm not sure why it's not allowing that. You know, I think it's probably just supposed to be integer from bool. Is that the deal? Or we could just simply say 1 maybe, because bool 32. Oh, actually bool 32 is like an enum. Okay. Alright, I wonder why they did that this way, but wiki dot, can I say wiki like bool 32 dot, okay, true. Well, I could pretty much just say dot true, yeah. All right, so that's how it works. Dot true. And here, dot true. And that's, yeah, that's all. So let's try now again. Cast as cards, const qualifier, expected type found const. Sure, let's make it var. And it seems to be working. Perfect. So now we probably have enabled the Vulkan features that we're gonna need. Dynamic rendering, synchronization 2, and push descriptors for now. Sick. So now what's next? So this is our reference tutorial. Let's see what's up. So yeah, we enabled the extensions and that features. Now we gotta basically actually use it. So we're gonna go ahead and like begin a command buffer, then begin the render pass. No, not this. Actually, we gotta do it this way. So this was like the old way of doing it. But now we actually gotta do this instead, apparently. You gotta say vkcmd begin rendering. And you just give it this kind of like structs, and you're good to go. Okay, sick. So now let's actually go back into our main loop. And let's see what we got. So I believe this is the part where maybe they were like, oh, actually no, because they were rebuilding the command buffers every time they were resizing. That's why. So honestly, I guess after that and before presenting, so what present does exactly? Let me see. Okay, so present, it acquires, wait, what? Simple method, acquire next image, wait for and reset fence. You know, current swap image, wait for the fence, reset the fences. Okay, all right, so the presentation part is at least handled for me, which is lovely. Q present. Yeah, that's pretty cool. Love that. Suboptimal. Yeah, fine. Let's just handle the recording here. So we're gonna grab our command buffer here. Oh, we can't actually. Does it not have any methods or what? Yeah, it probably doesn't. So we basically just gonna say gc.dev dot, and here we I guess record the commands that we need. In our case, it's gonna be cmd begin rendering. Yeah, so basically there's kind of like two versions here. There's begin rendering and there's begin rendering KHR. Now the KHR is like the one that you should use when you are in a version of Vulkan that the extension is not promoted, so it's not part of the core, so it's just like an extension. But in our case, since we're using Vulkan 1.4, which already have that as a core, we can just use this one without the KHR suffix. Okay, so the command buffer here is our command buff, and the p rendering info struct here. So we're gonna basically say vk.rendering info. So we could get some autocomplete, because what the heck. And let's see. So okay, so right now we could do some stuff here, and then we basically say end rendering command buff. Is that it? And it just returns void apparently, so that's cool. And obviously before that we have to start recording the command buffer. So what command buffers are, just to give you a bit of background. So this is not mostly like a tutorial, but I'm kind of just covering things as I go. So command buffers is basically, instead of like basically in OpenGL and stuff, what we had is that you would just like call some function on the GPU directly. And so you would kind of like send one command at a time to the driver through OpenGL calls, which really sucked. But here in Vulkan, what you do is you kind of like have a command buffer, which is kind of like just a list of commands, right? And then you basically send them all at once. Like you basically record them and you send them all at once to the GPU. In fact, here in the example that they have here in like Vulkan Zig binding, the one that we've seen, that we're kind of like basing our code on, they actually do something quite clever but doesn't scale very well, which is that they basically actually prepare all the command buffers they need only once at the start of the application, and then they just reuse those command buffers. They just tell the GPU to execute those command buffers we have prepared in the first frame, which is very performant because like you record only once for the whole application time, which is fine for static scenes, but once you get into some more dynamic scenes, this sucks, you know. So what you do, and what most people do using Vulkan that are doing any kind of like advanced application, they just re-record the command buffer every frame, which we're gonna do here. But yeah, obviously there is some performance, you know, kind of like inflexibility trade-off right here. But yeah, either way. Anyways, so it's kind of like, you know, if you got like two cities and you want to like deliver some packages using trucks, you wouldn't like just put one package into the truck and like tell it to go on to the other city and then come back and I'm gonna give you another packet or package. No, what you do is like you stuff as much packages as you can into the command buffer into the truck, and then you tell it to go to the GPU. Pretty much. So that's just a little background there. Anyways, so right now let's actually begin recording the command buffer. So begin command buffer, and here we're gonna give it the command buff, and here command buffer begin info. So let's say vk dot command buffer begin info. Okay, so let's see. Do we need any flags? I think so. Inheritance info, p next, and s type. Though I wonder if the example code is actually taking into account. You know what? I may actually just follow along with the tutorial for now. You know why? Because I'm not sure if the code that we have right here, right now in the Swapchain is taking into account that kind of like dynamic nature. You know what? Let's just go ahead and do this. So for the flags right here, what we're gonna do. So what kind of flags we have? So we have one time submit bit. Yeah, I think that's what we need right now. So we're only gonna submit it once, pretty much. But wait, one time submit. How does that work? I guess command buffer flags, usage flags, or how does this work? Let's see how they're doing the begin command buffer part. Okay, so they just say dot flags, dot one times. Okay, fine. Dot one time submit bit true, and there you go. That's sick. And in fact, yeah, it's fine. Whichever. Okay, next up, what we got? Here they're doing the buffer stuff. And finally we submit to the GPU. So honestly we could just like copy this part, and we do this before the present and after we're done with the recording. So the begin command buffer, and here we're gonna like end it. So gc.dev.end command buffer, so cmd buff. And is there like some error or something? Yep, so let's say try. And here the submit info. So we got one command buffer, and we're using command buff.handle01. Oh wait. I think this command buffer is actually from the copy buffer. Okay, I see. So where they're actually doing that, other queue submit. Alright, so they're doing it, I guess, copy buffer. Oh, what? Where's the other queue submit? That's interesting. Let's see what they're doing here. So they're getting the command buffer here. What? Okay, so they're just presenting and passing in the command, but I see. Never mind. So they probably do the submit for us basically. So we don't need any of this business, I think. Yeah. So we just record the command buffer and pass it to this function. Yep, there we go. So queue submit, and it passes it to the graphics queue. Yep, pretty much. Alright, so that's cool. So now what we got left pretty much is just to fill out this, you know, this Excel sheet of properties, and we should be good to go. So let's actually grab this part right here and let's see. So they're basically setting the image view to the Swapchain image. Yeah, this should be fine. Okay, fine. Let's see how we're gonna do this. Wait. Begin. Yeah, it should work, I think. Color attachments, depth attachments, render area. Wait, is it? Begin rendering, render info. So the render area, then the layer count, the color attachment count. Okay, fine. So the layer count is equal to 1, and the color attachment count is equal to 1. And then dot p color attachments, we're gonna say this, and I'm gonna say vk color attachment, I believe, or is it like attachment info probably? Yeah, what is rendering attachment info? Okay, so it's rendering attachment info. There we go. And here we need to fill out that form. So here we got the depth attachment. We're not going to be using depth stuff, though. Does it have a default value by any chance? Yes, they do have null and 0, so that's cool. Okay, so we don't need stencil either, but the render area, we need that part, so you tell it where you're going to render it exactly, and maybe even the view mask, possibly. We'll see. So the render area, let's start with that, fine. And here you got the extent. And for the extent, we're just going to go with the width 0 and height 0. In fact, does it even have like a default by any chance? Yeah, probably does. Probably does. So if we actually see the extent 2D here. No, actually it doesn't. Yeah, so we're just going to set it, fine. Okay, so width, height 0, and next up, what we got. So that's the extent, and the offset, I believe. Well, actually the extent should be 800, 600 for now, or too simply whichever. Oh, actually we already got the extent here, my bad. Yeah, so we could just say the extent is equal to extent, and the offset here is well, dot x 0 and dot y 0, and there we go. So basically, where do you start rendering in the screen, and the size of that rendering area. Okay, that's cool. Now what's next? Is there anything else here? Do I need the view mask by any chance? I don't think so. Render area? Not really. I don't think. Now the color attachment info. So the clear value here, where you set the clear value. So you need the color. So the color would be, so we're gonna go with the float 32, but it depends actually on the format of the Swapchain here, which format of the color we're gonna use. So I'm not sure what the code here did. So let's see what they're going for in the kind of like the format stuff. So here they got like an init function which takes in, the swap image.init, and it takes in a format. So let's see where they're using the swap image.init. They're using it here, and they're getting the format from init swapchain images function. Let's see where this thing is getting called. It's getting called from surface format.format. Where's the surface format here? So they're getting it from find surface format. and the preferred one is by default is sRGB. So that's cool. So they're basically, if they can find sRGB color space, then they use it. Otherwise, they just look for something else. So since I know that most people have sRGB, I'm just gonna hard code it for now. And for sRGB, you actually use float32. So cool. Now what this is, I think it's probably an array. Is that the case? Yes, it's an array. So here you give it the color. In our case, let's say red. And there we go. Let's just do this and we're good to go. Alright, so is there anything else we need to add here? Let's see. So the clear value and the image layout, the image view. Oh man. So the image view is gonna be, so where's our Swapchain image? Swapchain image. How are we gonna get the Swapchain image? I wonder. Oh, we could probably get the current image or the current swap image. Let's actually see how they're doing it in the example here, because we're using their abstraction. Let's see. So where they're recording the command buffer again? Probably in create command buffers. There you go. And here's our clear value. Okay, where they're getting the Swapchain image. The render area, frame buffer. So notice that we didn't need the frame buffer in render path here. The command bind pipeline. Wait, what the heck? Where is this Swapchain image? Oh, yeah, it's probably in the frame buffer actually. So where the frame buffer is getting created? Yeah, we probably just need to use, you know, the current image or the current Swapchain image. So let's say current Swapchain image, and this one gives me the fence. Oh, there we go, the view. Okay, cool. So that's the view there. Sick. What this does exactly? Yeah. Okay, cool. Love that. All right, next up, what we got is the image layout. Well, for the image layout, you're supposed to kind of like transfer the image layout into a proper transfer DST optimal for clearing it using some color. Actually, no, in this case, we're using a render pass, or in this case, like dynamic rendering. So actually what we want is color optimal, color attachment optimal. Next up is resolve image layout. This one we don't need. We only need right now the Lloyd OP. So what to do basically at the start of the frame. Is the stream, by the way, still working? Yeah, it seems to be still working fine. Okay. Cool. Hello, Dusheim. Welcome to the live stream. Alright, so for the Lloyd OP, what we're gonna do, we're gonna say Lloyd attachment Lloyd OP, and we're gonna basically clear the image at the start of the frame. And for the store OP, what we're gonna do at the end of the frame, we're gonna store it. We're gonna, I guess, keep it. So store, we're gonna keep the result essentially, because there is some times where you don't care or something else. But yeah. In our case, I guess we gotta store it, but yeah. Alright, so is there anything else we need here? I don't think so. The resolve is basically for MSAA and other cool passes, but other than that, we should be good to go. Unless if they don't have defaults, then we gotta basically define them ourselves. Anyways, so error union is ignored. Begin command buffer. Try me. Begin rendering here. We're good. So let's try this. Misinstruct field result. Oh yeah, it doesn't have like default. Fine. So the resolve mode is Let's see. So there is an average bit, sample 0 bit. Well, pretty much we're not gonna basically define anything there. Yeah, we don't need any bits there. So next up, misinstruct field resolve image layout. And for that one, we're gonna basically say, can we just say this? Would that even work? I wonder. I think it would. Type vacant is not okay. No. All right. So what we could use here for nothing. Does store op store short syntax work here? Yes, definitely it does. My bad, I forgot. There we go. In fact, even here you could actually say this, but I actually include it because of the autocomplete. Unfortunately, it doesn't work without it. But yeah. Yeah, the other fields, huh? Okay. Yep, I actually forgot completely about that. I think it's probably the same thing here, right? I guess. But yeah, the problem, what sucks about this is that the LSP doesn't really like that, you know. Yeah, so as you can see right now, it doesn't give me autocomplete stuff, which kind of suck. I mean, in this case, it's fine because I already wrote it. But when you're kind of like rewriting that stuff, but yeah. Anyways, so here, what we're gonna do? How do you do 0 here? What? Or none? Is there like a none here or something? Huh. Wait. Resolve image layout. Image layout. There's indefined. Okay, so it's called indefined. Yep, pretty much. And what's next? I think I probably gotta like define the other ones too, maybe? Resolve image view, maybe? No, it's already null handled by default, so that's fine. So that's cool. Let's see what else we got here. Expected array found. Okay. So it expected an array of vacant under attachment info, but it found that. Can we just PTR cast that? Because basically here we're giving it a pointer to one value, but it's expecting a pointer to an array. So maybe we could just say PTR cast. It would give us the green light, I guess. Let's see. Misinstruct field view mask in CMD begin rendering. Yep. Okay, let's see what is this view mask thing is. Is that like 2D or something? What is the view mask? View mask. I'm honestly not sure what that is, but we could check out the documentation. So where's the documentation? Did he use it here? No, doesn't seem like it. So probably set it to 0. But just to show you, you could actually check it out. You could say vacate rendering info Vulkan. There we go. And it's called view mask. Here we go. And what is it? It's a bit field of view indices describing which views are active during rendering, what is not. 0. Okay. If view mask is not 0, multi-view. Okay, so that one is just for multi-view apparently, so we just should set it to 0. Okay, because we're not using multi-view apparently. Multi-view I think is just like for, let's say, you know, VR glasses or something like that. I don't know, but basically when you have multi-views instead of just one. Okay, so how do we set it to that? Well, I guess we could just say 0 pretty much. Yeah. Next up, did I forget something else? No, it seems to be compiling now, but we got a crash. Why? Attempt to use null value. Okay, I see. I see. So basically what happened here is that we tried to use VKCMD. So this is why it's important for you guys to like try using or learn the raw binding, like, you know, raw Vulkan first rather than going straight to an abstraction. Because for example, right here, if I didn't understand all this crap, I wouldn't have no clue what's going on here, why this error happened. Right now I've seen this, I realized pretty quickly why the heck this happened. Which is, the thing is, we gotta basically, it couldn't load this VQCMD begin rendering because it's part of an extension. So I'm not sure how it's handled in the extension here. Maybe you probably need to like, I mean, how did it do that for the surface? Wait, so if we go back to the graphics context, maybe, for example, let's see what it did. So we got like the base wrapper here, device. Yeah, I'm not sure how it does handle. So basically we kind of need to load the functions, the Vulkan functions of those extensions somehow. And depending on like the binding, there's ways to do it. In this case, you know what? How about we check out the page here? Is there something about like extension loading here? Yeah, dispatch tails, but initializing the wrappers. Weird. Oh well, this is interesting. It's not saying how do you... I don't really see that it did anything extra for the surface. Because like the surface is also an extension by itself, so... Except if it like tries to automatically install any extension. Or maybe the binding isn't really populating those functions for some reason. That's very interesting. You know what? Let's see what's going on here. So it's pretty much doing some meta programming in Zig. So it's going through all the fields in the dispatch table and it's loading that function probably. Yeah, as you can see. So it's basically getting the name of that field. So yeah, that's pretty sick, bro. I love Zig. Anyways, how does it handle the extensions now? That's the real question. Is there something about maybe like dynamic rendering? Wait, dynamic rendering. Like some dispatch table for dynamic rendering. Yeah, that's strange. And it doesn't really say anything about it here. Yeah, can we see maybe issues? Maybe like dynamic rendering or something. Ooh, okay, so there is some issues about this. Let's see what are these issues. More defaults for struct fields. So this package only generates the Vulkan 1.3 variant of dynamic rendering functions. However, on some drivers supporting only Vulkan, keychar. Huh, really? About actually 1.2. I don't think this is related to my issue here. You know what? Maybe, what can I say? Where we're using the CMD begin rendering. So we're using it here. Can we actually try to debug this, by the way? Fine, why not? So I could also show you how you do it. Alright, fine. So first of all, we gotta make sure that it's using LLVM. Actually, wait a second, I'm gonna have a little break and I'm gonna come back. Okay, I'm back. I'm back. Alright, let's see what we had here. Alright, so we need to set up debugging pretty much. So for debugging, obviously, you gotta make sure that you're using LVM and LD, that's for sure. Other than that, what we're gonna do, sorry, anyways, so let's see Zig code work. And I actually have made a tutorial about setting up debugging, but we're gonna need it in this project too right now to debug what the heck is wrong with that part. So yeah, let's see. Alright, so Zig, and we're gonna go to tools, and what else? LDB. Let's check for LLDB, pretty cheap printers. And you're gonna download this file, and we're gonna bring it to our project, and we're gonna go to run and debug, actually extensions, and make sure you have LLDB. Yeah, code LLDB install. Alright. Okay, so acquiring code LLDB platform package. Okay. And I honestly forgot how do you like load the pretty printers. Let's ask ChatGPT really quick. How do you load LLDB pretty printers by in Zig VS Code? Yeah, there we go. Command script import. If it works, you're good. Command script import. And yeah, we also need to enable the error member. Yeah. So command script import. So as you can see, the AI have actually forgot about the enabling part, because it maybe assumes that it's enabled by default, but it's not. But yeah, that's something I had to figure out too at some point, but yeah. Anyways, let's see. So just waiting for this to download because I have reset my system, and so forgot to download code LLDB. Alright, is there any questions, by the way, while we're waiting for this? Acquiring. Actually, while we're at it, can we actually ask the AI for the extensions? And let's see if it actually knows or not. So, I'm trying to use Zig VK, like Zig Vulkan binding, VK begin, VK CMD, begin rendering function, which is obviously part of a core 1.4, well actually 1.3 extension, but I'm using Vulkan 1.4. Do you know about the LLDB init config file? I guess yes and no. I know that it could probably be used to like configure LLDB for the whole system, I think. But I don't know if there's like any extra special things you could do with it. I haven't really dug deep into it basically. But I'm using Vulkan 1.4. But using the binding loader, it doesn't seem to load that function pointer. It's wrong. What? Really? What does that even mean? I'm already doing that, so nope. No, I'm already using device wrapper. Didn't enable pointer, maybe no, it must be enabled dynamic rendering. And I did enable dynamic rendering feature. So far it didn't give us any solution. Though, I mean, I could just do it manually myself, like just go ahead, load the dispatch function myself, manually. But I wonder if like there is a better way in the binding, pretty much. So yeah, after loading, you didn't choose. Nope, I did. Driver does. I did. Quick fix summary. And my driver does support dynamic rendering. Alright, so if you're already using enabled, real likely issue or generated without Vulkan 1.3 enabled. No way, I don't think so. Vacay.xml? Where can I find out about that part? Really? Ain't no way. What? I can't really find that. Did it just hallucinated that or what? I mean, there is a version, but it's for XML. There is a Vacay version 1.4, right? Yep, there is. So I guess it's probably taken into account Vulkan version 1.4. May exist only as or not generated at all. Do you have or only if you only have? Honestly, actually, if it wasn't there, it wouldn't actually be a part of the functions themselves, really. So that sucks. Or I could just try to enable the extension and call it a day, even though it's core. So that's strange, but weird. But anyways, we'll find out more information on what's going on in the debugger. So pretty much, I think right now the code LLDB have got like installed, right? Or no? Well, not this one. I mean this one. So that's cool. Now the next thing we gotta do is go ahead to here and run and debug code LLDB, and there we go. And the program that we're gonna launch is workspace root slash well, zig out slash, and what else going on here? Could check who zig vacay. Okay, so that seems to work. Now what we're gonna do here is, I believe, commands, right? Yeah, init commands. So there's init commands, probably init commands, and here we probably say script, I guess, command import or something like that. Let me see what it did. Wait, yeah, there you go. Init commands, command script import, command script import, and then you basically just copy this file right here. This, well, you could just say LDB since it's in the current directory, pretty printers.py, And next step, we gotta also enable them. But I don't remember how do you do that. So what we're gonna do, we're just gonna go ahead with this and find out ourselves. So let's just try to debug, I guess. But before that, let's try to put a break. I already did that. Let's remove this 5-minute break here, and let's just launch this. And Kurochaku Zig Vacay does not exist. Does it have an existential crisis or what? Let's see, Kurochaku Zig Vacay. Workspace / zig out. Oh yeah, /bin. Let's see, launch. And I guess we're in. Yep, there we go. Okay, sick. So right now, I believe it's probably still not enabled. So we gotta figure out a way to enable them. I don't honestly remember how. So we're gonna ask it really. How to enable, so that's not enough. We gotta enable the pretty printers. How to list them first. Because honestly, I don't remember the command at all. Nah, I don't think so. There you go. Type summary list, I think. But not really. Wait, let me just see. So type, I mean, let's just say this. But no, that's not it. Type category list. Yep, exactly. That's what I really need there. There you go. So, and here we go. So there is a category called zig, zig.lang, and zig.std. So you gotta enable these. So how you do that, you say, I guess, type category, and whoops, probably enable, I would say, and zig.lang and zig.std. And there we go. Look at that. It got updated here, which is sick. So what I'm going to do, I'm just going to copy this thing that we have here, the command that we've used here. And I'm going to come back to lunch.json. I'm going to add this command here. So yeah, there we go. Okay, so this is how I actually figured out how to debug Zig programs. Anyways, so, okay, cool. Now let's see what's up here. So we got the GC, so, and vacay-b, vacay-d. Where's vacay-d? Or like device, I guess. So the device, the wrapper, the dispatch. Okay, so this is the dispatch table. And the dispatch table, as you can see, is just like a bunch of function pointers that are loaded from the DLL or like the shared library or whichever. And notice here that some of them are actually null, which means they're not loaded. And in our case, oops, what the heck? Okay, let's see. Can we actually search? Wait, can we actually search this one? Can we say Control F? Not really. Well, that kind of suck. But okay. As you can see, all of these are null. So what we're looking for CMD begin rendering. So where's CMD begin rendering? CMD begin. Yeah, no way. I'm not gonna go through all this. Begin rendering. Yep. Nope. Where is it? CMD. Does it actually show that? No, it doesn't. Interesting. Okay, let's try to... Can we try to log a message and say like gc.dev.cmd begin? I actually had never tried this before, this part right here, this one. Okay, does it actually print that? Oh, well, I actually attempt to use null value, the problem that we have already. Okay, how about let's say const x is equal to gc.dev.dispatch. Well, .wrapper, I think, yeah. .dispatch .vk cmd begin rendering khr. How about that one? Okay, and let's just also have y here, and y would be without the khr, and let's see for ourselves. Let's see. Now let's just debug this. And let's see what the values of this. So this is null, and this is null. So both aren't loaded. So you know what? I think I'm just gonna load the function myself and call it a day for now, at least, maybe. And it would be maybe good way to show you how it works. So fine. So basically cmd begin rendering is equal to, and let's figure out how you do this. So like vkd, or what we have here. Yeah, gc.dev .wrapper. Is there like so do we have like a load? No, not really here. So does it have like a load function here? No. Okay, no. How about here? Nope. Okay, you know what? How about we try... Where is that load function that we got from STL? What is it called? Yeah, it's in the other place. It's called vkget instance proc.ddr. Yeah. But here we need device proc.ddr. But the device doesn't have that for some reason. So okay, can we say wrapper.dispatch or like .vk, or wait, get proc.addr? No? Nope. How about the dispatch? Get proc.addr? Not either. Okay. How about the instance? So get, yeah, there we go. Instance get device proc.addr. And here we could give it the device. So like the gc.dev. Maybe I'm gonna need to give it the handle actually here, right? And here the name of the function we want to load, which is in our case is cmd begin rendering. This is actually what the binding does for us under the hood, to actually load all those function pointers essentially. And we should be good to go. Now let's see if this at least works. Because if this at least works, we know that it kind of works, but something's stopping it somehow, I don't know. And why, where is it? Oh wait I gotta actually like well, first of all, let's try to use this, can we? Well, not really, because this is like a kind of like an opaque function. It doesn't know its type, so we gotta actually like convert it into its type, which I believe we do it using ptr cast. And we're gonna ptr cast this into what? Into vk.pfn cmd begin rendering. There we go. So that's the function type of that. And is this like optional or something? I don't think. So we could probably just say this before the PTR cast. Okay, cool. Now, does this work? Maybe, let's see. So how we do this? So zig build run, or just zig build. Cool. Now let's actually try to, whoops, what the heck? Attempt to use null. All right. Wait, I forgot. So Vicky CMD begin rendering. Because like the binding actually just removes that prefix of the function. So let's use that. What? So we couldn't load Vicky CMD begin rendering at all. What the heck? KHR. Well, that at least tells us that this is not a problem with the binding, apparently. So, you know what? Let's try to just add that into the extension. I don't care, and let's see how that would go. So let's go to the graphics context. Paketo extensions, KHR Swapchain. Is it a device extension or is it an instance extension though? Dynamic rendering. Okay, where's the wiki for it? You know what, let's just copy this. And let's paste it here. And let's see the registry, I think. So it's a device extension, okay, fine. So what we're gonna say is wiki extensions. Oh, wait. Maybe it's this way. So wiki.extensions dot KHR. And what is it called again? Dynamic rendering? Yeah. Okay, and there is .name. So there's no other things. There's just the name and the version. Cool. Alright, so if we do it this way, and we build, and hopefully at least this would work. Okay, right now, as you can see, we did get a function pointer, so that's cool. Now, what if we don't have the KHR? How about that? I think that also works. Yep, it also works. And in fact, maybe even like it would work out just as it was before right now. So if we say try gc.dev, but hey, at least you learned how you could load, how like the function pointers of Vulkan gets loaded, how to debug kinda, but yeah. Anyways, so let's go to the next step. I think right now, let's try to actually launch this. We have some problem here now. Attempt to use null value. Oh, really? Let's just try zig build run. And let's see what we got next. Is CMD begin? So expected error union type found void. Oh yeah, my bad. Let's try now. And now we have an error. Wait, what? Is it really the same problem right now? That's very strange. I'm pretty sure it was working now. What in the world? Let's try this again. Yeah, but like what? So what's missing? how about we use the KHR version? Now you have a problem with the end rendering. Okay. So apparently it doesn't work that way except if you use KHR. Unless if somehow it's not... Okay, so we got a Vulkan window in red right now, which is perfect. Just getting a Vulkan window in red is as hard as it gets. But it's actually a little bit easier from there to some degree, especially when you got a triangle, because once you got a triangle you could make thousands of triangles. The problem becomes in going further, like lighting and so on. Yeah. Alright, so obviously we do have some validation errors right now because we're missing some few things that still make this work, but it's not perfect. But yeah, I think though... alright. So I'm kind of thinking what we're gonna do next. Begin command buffer, begin rendering. So we could fix these like layered layout stuff, but yeah, I think honestly maybe, yeah, let's just try to fix that. Fine, why not? But you know what, let me try something here. Let's make sure that we're actually using the latest Vulkan version, because maybe I might be mishandling that stuff and that's why we had those problems. Yeah, maybe, just maybe. So how are we gonna do this? Well, we could basically put a breakpoint after we create the instance and see for ourselves what arguments Vulkan is getting. So where we're creating that here, like the graphics context, and let's just debug, and there we go. Okay, and let's see. So when we create the instance here, the Vulkan version that is... Oh, okay. So this is the problem all along, bro. So the Vulkan version seems to be wrong for whatever reason. It's actually using 1.2, and that's why this didn't work. My god. So I actually did set it to Vulkan 1.4, but when I adopted like the example code, like imagine this whole detour of debugging and even AI couldn't figure it out. And so all this because the version is wrong. God damn. Okay, so let's actually fix it in the example code. Like not example code, but like the graphics context code that we got from, that we copy pasted. So the copy pasting is the devil here pretty much. Okay, so as you can see, the example is using 1.2. So that's why the core versions didn't work. That's why. Let's go with 1.4, and now we should be able to hopefully remove those extensions. So remove this. I should have tested this theory a long time ago first. But I just didn't somehow. I don't know. Anyways, let's go back into main, I think. Or what was it? But hey, at least we set up debugging, you know? And they tell you about like function pointers, how you can load it yourself even. But anyways, so where we were, yeah. So we removed the extension name here, and the other thing is that we shouldn't use the KHR versions now. Since it's core, we could probably just use this one. So begin CMD begin rendering and end rendering KHR. Okay, cool. Now if we try to zig build run, now they should work just fine. And there you go. So those are all like the Vulkan functions that it's getting called every frame. because we're actually basically enabling API dump here. And if you enable this layer, it just shows you all the Vulkan functions that are getting called pretty much. And there's also like the validation layer, which would tell you if there's any problem with your code, with your usage of the API and so on. But yeah. Anyways, so let's actually try to hopefully figure out how we could like convert the layout, because right now it's actually working, but it's giving us like validation problems. Because actually, let me show you. So like validation, and you're gonna say zig build run, and look at that. So this is the validation errors that we have. Okay, so that's a lot. Let's see. Let's start from the beginning. It has completed, must check command buffer fence. Well, must check. Okay, where's the image layout stuff? Yeah, there you go. So as you can see right here, for example, just as an example of a validation error, so we got error validation. The message is from vkq submit, you know, and the p submits 0. So command buffer vk command buffer and the address of the command buffer expects vk image and the address. Subresource aspect mask, blah 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 blah. To be in layout, vk image layout color attachment optimal. Instead, the current layout is vk image layout undefined. So the Vulkan spec states for each element of p rendering info, p color attachments, if image view is not vk null handle, when the image view is accessed, it must be in the layout specified by the image layout member of the same element of p rendering info color attachments. So we gotta basically convert like or transition the image layout. So why Vulkan have image layouts? Why bother? We didn't have those in OpenGL. So pretty much in the GPU, you don't like just store all the images alike. Like you don't just store all of them like as simple arrays of pixels. No. So depending on the access, how you access that data. So like for example, it could be compressed or it could be optimized or like put in storage in a way that is optimized for some certain access pattern, right? And so the GPUs have a lot of this for all sorts of cases. So that's why we have image layouts, which are very annoying, but yeah. All right, so how do you actually transition the image layout? Let's see. So before we begin the rendering, so because here it is expecting it to be color attachment optimal. Now you could set this to another like image layout, but it's gonna, again, the validation layer would tell you that this layout that you set isn't the most optimal way or the most optimal layout for a clearing or like for a rendering operation, essentially, because depending on which kind of operation you're performing in the GPU, you're gonna need a separate image layout. All right, so here hopefully we gotta be using synchronization 2. Yeah, so the extension. So we're gonna say vk pipeline barrier, I think, or isn't it pipeline barrier? Yep, there you go. So there's barrier and barrier 2. So barrier 2 is the one that is from the extension synchronization 2 that we enabled before. So I guess I'll just use that directly instead of having to refactor later on again. So what we're going to say here is command buffer, and the dependency info is right, an address to a dependency info. There we go. Now for the dependency info, what we got here, so we could like put memory barriers for images, for buffers, for all sorts of things, because the GPU is a beast of parallelism and like you have a lot of caches and so on, so you gotta make sure that every operation that needs some particular, let's say some memory is visible or some image in a particular layout or whatever, you kind of put a pipeline barrier. So the next stages in the pipeline actually waits instead of being overlapped, because basically in Vulkan by default it just like kind of like overlaps most operations. So the GPU like basically like tries to execute as much operations in parallel as possible. And the only way to actually kind of like guarantee ordering is by using like pipeline barriers or using semaphores and fences, which are actually being used by the Swapchain. And the Swapchain is the one that is, kind of like responsible for giving us images and so on. But yeah, like from the window. But anyways, so here what we're going to set it to is, I believe, the images, right? So image memory barrier count is equal to 1. So basically you could like batch. As you can see in Vulkan, there's a lot of emphasis on batching. So like if you have multiple barriers, you better put them in one single call, kind of like this, if you can. But yeah. All right, so here p image memory barriers, and I think we probably get a PTR cast this since it's expecting, I believe, maybe an array. No, I mean, I'm not sure. Wait, why can't I see this? So where's the image barrier, whichever image memory barriers? There we go. Yeah, it's expecting kind of like an array. So yeah, let's just say PTR cast, fine. And let's say vk.image memory barrier 2, and what we're gonna say here is .image. So our image is, well, the Swapchain current image. So Swapchain, whoops, what the heck I did there? Well, that's strange. Yeah, that's fine. So let's just say image is equal to Swapchain dot current image, or Swapchain image. I mean, we could probably say current image, yeah. Yeah, that would work, fine. And what else we gonna do here? Dot, and well, we gotta fill another form, right? Another Excel sheet. Let's see. Oh boy. So this is what they mean when they say Vulkan is very insane. Very verbose. Anyways, let's see what we got here. So the old layout, the new layout. So the old layout, in this case, it's basically just, I guess, undefined. The new layout is that we want is like, what is it called? Dot color attachment optimal. Next up, we got the src axis mask, which is supposed to be, in our case it should be none. Do we actually have that? Yeah, how the heck do you do that? Wait, let's see the axis mask. The axis mask. Well, where is it? There we go. Axis flags 2. I guess we should just like leave it empty. Yeah, it's probably the case. It's probably the case. So what we gotta do is probably just say this. And that should work, I guess. And there we go. Now DST access mask is equal to, we want it to be able to write to it next up. So we're gonna actually set it to, I mean, there is a few writes here. So color attachment write bit is what we want here. So we gotta say true, and there we go. Next up, what else we got? The DST family index, the DST stage mask. So the stage mask that is coming next is probably the color attachment output. Yeah, true. Next up, so the DST key family index, I'll probably just like ignore that. It's probably just the first Q family, hopefully, for now. So src Q family index and src stage mask. Yeah, for the src stage mask, it's pretty much nothing, maybe, or I mean, what they're doing here, wait a second, if you go back to this tutorial, for example, they should have that. There you go, image layout transition. So they're going from, in this case, color attachment optimal to layout present. Bottom of pipe. And there we go, top of pipe. But I believe there is like one for none or something. Wait. So, I mean, we could just say top of pipe, I guess, fine. Wait, let me add a comma here, and there we go. Is there anything else we need here? There's probably sub-resource range, oh my god. And the aspect mask is the color bit, true. And the base array layer 0, base map level 0, layer count 1, and the level count 1. And I hope they have default values. No, they don't. God damn. Anyways, let's go to base array layer 0 and base map level 0. Is there anything else? Nope. Okay, so that's it. Okay, cool. What's next? So that's the sub-resource range. Okay, so I guess let's try this already. Yeah. So there's probably a lot of errors right there, but let's see. So you build run. So misinstruct field src family index. There you go. And misinstruct field dst family index. Okay, sure. So src family index is essentially the, what is it called? gc dot, I guess dot div maybe? No. gc dot what? Let's see. That, yeah, there is present queue and I believe graphics queue dot family. Yeah, and the dst, or I believe there was like some way to kind of like essentially say you don't care. Wait, yeah, queue family ignored. Okay, so if there's like no actual queue, you know, transfer of ownership, then you could just do this, I believe. Yeah. All right, so that's cool. Next up, yep, that's pretty much it. All right, that's a lot of crap. Okay, so that works. So now let's just complete the transition. So this is the first one. And the second one is after we end the rendering. And obviously before, wait, we're ending the command buffer, really? Wait, what? Yeah, actually that works, yeah. So after that, after we end the rendering, we're gonna basically transition the image layout to a present src layout, which is the layout for presenting images. So what we're gonna do here, we're gonna say, so this is gonna be the old layout now, and the new layout would become present src khr. And the src access mask, this is gonna become now the old layout. Whoops. And the new layout is nothing. Sorry, the new access mask is, I believe, nothing. And the src stage mask, well, the source, so it would become this, the dst. And here we're gonna say the bottom of pipe bit, yeah. And the sub-resource range, same thing. And yeah, that's basically it, I guess. I wonder if GC have like some sort of, you know, helper function for this. I don't believe so. Yeah, I don't think so, because they're not using dynamic rendering. Yeah, so no. But anyways, so I believe that's pretty much it. So we go from color attachment to present. Yeah, I think that's good. So at least that would fix part of the equation. hopefully. And okay, so here, oh yeah, I need to reset the command buffer every time. So before we begin the command buffer, we have to make sure to say try gc.dev well, reset the command buffer. There we go. Command buffer, how do we, yeah, command buffer, and the flags would be what? Release, no need, and we're good. So does this actually, yeah, it does return an error. So okay, so that's should fix the other errors too. Now, is there anything else? Oh boy. Okay, so I believe there's, wait, let me try to clear this and try again. Was created, which was created with, oh yeah, I see. So the command pool, who's creating the, yeah, me. So this should have some flags, I believe, right? Or no? Yeah, but let's just say vk.command pool create info here. Now we could see the flags dot reset, I believe. Yeah. So you basically add this flag so you could able to like reset an individual command buffer at a time. And I guess that's it. Yeah. There's also transient. I'm not sure if it applies here, but anyways, so that's one. All right. Let's actually clear this and try again. Must not be independent state. Yeah, there's probably some issue with the, what is it called? Well, the synchronization of the command buffer, because probably the Swapchain code right here isn't taking into account the fact that we're not pre-baking the command buffers, possibly. So I guess I'll gotta figure that out off camera, so this wouldn't become insane. So on active before, we must check. Yeah, so that's the only error left, which I'm gonna check in off camera. So yeah, I think at least we got like a colored window in this stream. So maybe next stream we're gonna get a triangle pretty much. So yeah, that was it guys for this video. Thank you all, or this live stream. Thank you all for watching. Is there any questions before I end the stream? Please let me know. Alright, so I guess we're good. Alright, goodbye everybody. Thank you all for watching. See you in the next one. Goodbye everyone.